So in the first, we will start about the PLC programming concept. So let me start this. So in the first way, we have this concept, PLC idea. So how to recognize in the industries. So how you can check in industries, it hang on a PLC for a machine or not. So firstly, you have to look around the area, recognize the area. Here is automatic work and manually work. So where it use the manually work, so you can't recognize and see about the controllers and sensors and actuators and all. And in the automatic area, you can see all controllers, sensors and actuators, valves and etc. Field devices you can see in the automatic industries. So here, as you can see, this image, this is the machine. It's a have the automatic work. So how it is work? It's a hang and it's a belt of a body and manufacturing a car, truck body and bike body. So all bodies have made by the automatically. So in the automatically work, it's use the control the controllers. Its name is PLC Programmable Logic Controller. So is the PLC have the ladder logic. It's have 5 languages. It is used to 5 languages for the controlling a industrial control application. Here we will learn about the ladder logic. Logic is the commonly used and widely used in a world because it is a understanding way is the very it can be say easy. Okay, so here we will use the ladder logic. So ladder logic is used to develop software for programmable logic controller PLC that are used in the industrial control application, where we want to use and control the application in the industries. So you can take and hang on a PLC for your control process. So we will move on the next. Is the next we have PLC ladder logic programming. So if you are going in our industries and look the control process monitor, so it is look like as a. So you will see this pictures. So before you don't understand, so you can't recognize this term. Okay, and in this term you have like yeah, this. So this panel is recognize the ladder logic. It's a ladder logic. It's look like vertical and horizontal rungs, and it's this is the instructions. This is the instructions. So how it will recognize? How it will can be find it is right and it is wrong. So we will discuss in our training. So here I just tell you, we will move on this process. Okay, so our ladder logic programming look like this type. Okay, in the vertical line, in the horizontal line. So in the horizontal line have a power supply and vertical line have instructions, many more instructions. So it will this type. Okay, and in the next way, we will move in the PLC diagram. So as you can see, this is our PLC, this one. So this is the Allen Bradley PLC. Okay, Allen Bradley PLC, which is series of 1400 Allen Bradley PLC. And this is the PLC diagram. Okay, so a PLC.
Sorry, sir.
Yeah.
The spelling for Allen Bradley.
Yeah.
I want to search it more.
Yeah.
Spelling.
A double L E-N
E
P-R-A-D-L-E-Y.
N N E
Yeah,
double L E N.
yeah, just wait. I'm typing here. Yeah, this one. Alan Bradley.
Okay.
Yeah, and series that 1400. Okay, yeah, Alan Bradley series 14.
Okay.
Okay,
So you mean that the ladder logics you are going to develop
yeah,
in Alan Bedry PLC will differ from the ones maybe we develop in Siemens, in Beckhoff PLCs. Are they different or similar?
yeah, similar. Logic are
Similar.
all PLC have similar logic for control
Okay,
process.
fine.
Yeah, no one is different. All PLCs have similar logics. Okay, yeah. We will come through of our Siemens, Allen Bradley, Honeywell, and all. We will see. Yeah. So here, this is a Allen Bradley PLC, and as you can say, this is the display. This is the LEDs which is show the error, program updated and run, and program run, download, and our inputs are on or our outputs are on and off. So all the things we have to relate our LED. Okay, if our inputs are energized, then it will on. And this port is a communication port which is connected to our other controllers, and it can be connected to our PC, laptop. Okay, and this is the buttons. It can be change and move for our PLC function. And these terminals are represented to our inputs. Okay, and these terminals are represented our outputs. Okay, devices are connected to the input and outputs module with the PLC. Okay, so this is the PLC diagram. So our PLC are connected to our laptop or PC with the communication port. Okay, it can be RS-232, it can be RS-485, it can be Ethernet port. Okay, and our PLC are divided with the sectional wise. Okay, it is divided to the sectional. So it's a have the part of power supply, processors, and input module of digital output modules, analog input modules, analog output modules, and it's have more communication ports and LED ports, LED sections. So it is the divided with the section wise. Okay, all section are built and make a whole PLC. Okay, and how to connect our field input devices? Field input devices will,
Sorry, Ashish.
yeah,
How can you recognize that these input ports are analog and which ones are digital?
yeah, analog or digital, na? So in the PLC have mentioned D for digital and A for analog. Our PLC, if you are buying a PLC in a market, then you spoke to uh, manufacturer. So it's tell you it's a input and outputs. Okay, when you are buying a PLC, so you are going to speak of inputs and outputs. Like we have used our 16 inputs and 16 outputs PLC. We have used our 32 inputs and outputs PLC. Okay, it's a terminal of the number of terminals, and it can be if you are buying a 12 inputs and outputs PLC, so you got 10 inputs of digital and 2 inputs of analog. So it is mentioned in the top of the terminal. Okay, so here if you are zooming this PLC, then you can show is the D is the digital and A is the analog. Okay, yeah, and in the field input devices are connected to our input modules. It can be digital, it can be analog, and our output devices are connected to the output modules. It can be digital output module and it can be also analog output modules. And we will move on the next slide. Yeah. So in the next slide, we have PLC Logic Storage. So how to store a program in a PLC? According to software, industrial application have to controlled. Okay. So in our various type of PLC are available in the market. Okay. And various manufacturers have own software, and our Siemens have TIA Portal, and our Allen Bradley have RS Logic 5500. Okay, and Delta have WPL Soft, and Omron, and Honeywell, and it's have two different software, but logic are same. Every PLC have logic same. Okay, and here we will see how to recognize, how to store a logic inside the PLC. So this is the logic. This is our logic, which is made by oneself. Okay. And in the first, we will put our input devices, and our input devices are connected to our input modules, PLC input modules. Okay. We will discuss now in the previous slide. I move on the previous slide. Just wait. Yeah. Here we will see now these are our input modules. Okay. And these are our output modules. And here we will connect in the input module connect. We have connected to input devices. It can be sensor, it can be push button, it can be switches, it can be toggle switch. Okay. So these are connected to our input modules. And after we have make our own logic in the software. Okay, and after making the program in a software, then we will download program in a PLC with the communication cable. Okay, and this is our logic, which is how to store. It is stored with the communication cable after downloading the program. Okay, I will show how to download it when we will go na software mode, software step, then I will tell you. And this is our output module where we will connect our output device. It can be solenoid coil and motors and light. Okay, it can be connected with the output devices. And in the next, we have ladder logic diagram. The name ladder logic programming came from the fact that the program at the end looks similar to a ladder with different instructions and rung. Okay, so I think you don't know what is the instruction and rungs. Okay, so I will tell you.
Yeah.
So these are this line. This line is called as a rail, RAIL, rail. Okay, and this is the this number are show our rail number. Okay, it is the one rail number, it is the 2 rung, and it is the 3 rung, and this is the 4 rung. Okay, and this is the rail. It is the positive rail, and this is the negative rail. This is the okay. When we are connecting our lamp, Yeah, and just lamp we are connecting with the battery, then we will connect one terminal with the positive and one terminal negative. Okay, so it's complete the path. Okay, and we want to complete the path on PLC, then we will connect our rail in the left side, and in the right side we have negative rail. Okay, and our positive rail have a voltage, some voltage. Okay, it can be 12 voltage, it can be 24 voltage. Okay, it is the it can be say that line rail. Okay, and it can be say that neutral line rail. Okay, and these are, as you can see now, these are instructions. Okay, so it's a lot of instructions are used for making a control process. Okay, so one by one we will discuss after doing this training. Okay, after complete this session, we will learn one by one all instructions. So here, this is this line. Okay, these line are represented our rung. Okay, I will tell you
Okay.
now, this is the this rung. Okay,
Okay. Okay.
this is the
Okay.
rung, this is the rung, this is the rung. Okay, this is the end rung, which is show here we have to end the program. Okay, these rung are represented end of the program. Okay, and now we will move on the next slide. Input and outputs. So what is the inputs and what is the outputs here? It is the software part. Okay, so this is a ladder logic diagram, as we know, and these line are represented our rail. Okay, and
Okay, fine.
these line are represented to
Lungs.
rungs. Okay, and these symbols are represented to instructions. Okay, and this is our input coil and this is our output coil. Okay, output coil, it can be suppose light, motor, solenoid coil, and etc. And our input coil, we can take a switch, sensor, and push buttons, and temperature sensor and pressure sensor. Okay, and these number are showing our rungs, how many rungs are working in a program. So as you from this number you can find. Okay, in PLC ladder logic, generally the inputs are placed to the left of the ladder logic. Yeah, when you are making a ladder logic programming, then it's is the it can be say that yeah, always always place the input instruction in the left side. When you are making a ladder logic, then always place the inputs in the left side of a program. Okay, in this side, and in the right side you must to add the outputs. Okay, this is the right side and this is the left side. In the left side you must to add our inputs, and in the right side you will connect our outputs. Yeah, as you can see, as you can read, outputs are on the right side. You will learn later in the course that not all inputs and outputs are necessarily connected to the physically device, but for the sake of the simplicity, let's assume so far now. Okay, so in the next step, we have PLC ladder logic diagram designing. Okay, how to design a program, a rung. So as we have to discuss, these line are this is a left power rail. Okay, it can be say that positive rail, and this is the right side, and right side have ground rail. right power rail, ground rail. And as you know, our ground have no voltage. Okay. And this is the flow of our logic. Electric current flow from this side to this side. Okay, when we are connecting this path, then our electricity and logic flow from left to right side. Okay, and how to design the program. So here I present a simplicity of a program. This is the rung 1, this is the rung 2, rung 3, and this is the these rung are represented to our end of the program. Okay, when we see this rung,
Sorry, Mr. Ashish.
yeah,
I can see that there are special brackets for input, special brackets for output. Is it that it should be the year? Can you interchange them?
yeah, in the Allen Bradley PLC have this type of input coil. Okay, and when you are moving on a Siemens and other brand of PLC, it can be see look like, okay, it can be see look like instructions. Okay, and generally in the Allen Bradley PLC have used this symbol for the output.
Okay, fine.
Yeah, and yeah, and some PLC have this type of outputs, this type. Okay, and some PLCs have this type of coil for the output. So it's a depend of PLC company. Okay.
Okay, fine, fine.
And the next we have PLC ladder logic programming designing example. Okay. So these are the two example here, in the left side example and in the right side example. So in the left side example, we have to use 1, 2, 3. Okay, we have used 3 inputs in the left side. One is that push button, one is sensor, one is limit switch, and all inputs have different address. As you can see, I.0/2. Okay, all inputs have different address. Okay, and in the right side it's have our outputs. So one we have a light, second motor, and third actuator, and our outputs also have a different address for working. And as you can see, O/0/2, it's a represented our actuator. Okay, when you are pressing the limit switch, then it will flow our electricity look like, then our actuator are energized and move forward. Okay, and in the right side program have some mistakes. Okay, when we have to use the first, second, third, and fourth, we have used four rung. Okay, we have four, and in the first run we have instructions. In the second run we don't have instructions, so it will show the error when you are downloading the program for going to the PLC. Then it is not acceptable by the PLC, because uh, uh, it's have the it can be said that runs, it's have the no instructions run. Okay, because this run haven't any instructions for controlling the process. So when you are downloading this program for the PLC, then you will show the error. Okay, and in the third rung we have to use a switch 2, and in the right side output our fan. Okay, and these are our example. And here we will stop our first step for understanding the simplicity of PLC programming. So have you any doubt about this right now? Any
No,
any any question from this side?
the training is so exciting. All the questions I had, I was asked, I are the one that I asked during the session.
Okay. So
Yeah. Can we proceed to the next slide? I mean
today,
the second tutorial. Yeah.
yeah, okay. So just hold down. Yeah, just wait. Yeah. So we will move on the our next session slide. Input instructions. These slide are totally depend on our inputs. Okay, because a lot of inputs are working in programming. Okay, so here we will learn about the input instructions. So in the first way, we have to learn input instructions. The way we write the input is as follows, as two bars. Okay, facing each other representing the inputs, and in the order to differentiate between physical input devices and input within the software, we will refer to the input in the PLC program as an input instructions. Okay, and in the input symbol, how we have to represented this symbol for our inputs. Okay, we have two bars, one that and one that. It show our inputs. Okay, the next slide, let's take a look at what inputs means in PLC ladder logic programming. I will be using a green highlight in the slides here, similar to what is used in the Allen Bradley software. However, it will very similar in any other PLC types. Different colors might be used in the different software, but they all indicate the same concept. Okay, when our instructions are energized. Okay, when our inputs are energized, then it will show the highlighted, green highlighted, and it can be changed on our software. Okay, but it's highlighted. Okay, and these instructions are not highlighted, so it's mean the not energized. Okay, and these also are highlighted, so it means our inputs instruction are energized. And when we are pressing this button and our current flow in the left to right and reach from our outputs, then our outputs are also highlighted and it will show our outputs are on. Okay,
Sorry, can you repeat that concept?
when we
Starting
are,
from when energized, de-energized.
yeah, when we are stepping, when we are forward the logic from left to right as this. Okay, when you are pressing this button instructions, so it will energized, so it will forward the signal to next instruction, and our logic or flow look like, and after that our output instructions are energized and it will show as a highlight. Okay, it will highlight, and it means highlighted means it will energized, it will turn on. Okay,
Okay, fine.
yeah, when our logic are
And,
moving left to right, then our output, it will on, it will turn on. Okay,
okay, and what about that the parallel connection on the bottom? Will it not be that when the signals will distribute it into two before producing an output?
in the in
No,
this
not
run,
that one. No, the
this
top
one,
one.
this one,
The one at the middle.
when we are
The one
pressing,
at the middle.
when we are pressing
The one
this,
at the bottom one, the double bottom.
this one,
Yeah.
Yeah, I will explain what is that. Okay.
Okay, fine.
Have you question now? What is that? So I will explain during our whole session, because
Okay, fine.
it's have a different operation. Okay, it is called it
Okay.
as a holding. Okay, in a PLC ladder logic programming, it's called it as a holding. HOLDING, holding. Okay, it
Okay.
is the
Okay.
holding operation. I will
Okay,
explain.
fine.
Yeah, I will explain slowly. Yeah. So we will move on the next slide. Yeah. There are two main types of input instructions: examine if close, XIC, and sometimes called it normally open. And second is that examine if open, XIO, and sometimes it's called it normally closed. So this one, these symbol are represented to our XIC input. Okay. Here we did learn about inputs. Okay. So here it is the partition of inputs. Okay. So there are basically there are two partition of our inputs. One is that normally open instruction, and one is that normally closed instructions.
Closed. Okay.
Okay. And it's have a different name of examine if open and examine if closed. Okay, normally closed instructions have examine if open name, and normally open instructions have different name of examine if closed. Okay, note the only difference between them it's that the XIO has a sidebar indicating that it is already closed, and we are checking if it open. Okay, so these line are saying our normally closed instructions, when you are add the normally closed instruction in your program, in your PLC program, then it will directly in a initial way it will on. Okay, because it's have the mechanism of turn on condition in the initial way. Without energized, it is the turn on condition. And when we are turn on with the pressing of push button and other, then it will energized. Okay, we can say that our normally open instructions have external source for the energizing. Okay, and it can be say that for our normally closed instructions haven't any energized source. Okay, for energized haven't any source. When we are putting in a program this one, then it will turn on automatically because it's have the mechanism.
Closed. Closed. Okay, it's closed.
Okay, so in the next slide, yeah, in the next slide it's a explanation. Input instruction on and off condition without trigger of the input instructions. Okay, so these symbols and program are represented without trigger of the input instructions. So these symbol of normally open instruction. Okay, and when we are making a program in a PLC software, then it will so look like. And when we are going to run mode of our program, then our these left run are energized, then it will flowing the current. Okay, and without pressing it will not transfer the signal from other instructions. Okay, and when we are putting and adding, when we are add normally closed instructions in our program, so it will energized. As you can see, it's automatically energized. And when you are pressing this instruction, then it will um, unenergize, de-energize. Okay, it's used for stop. Okay, when we are going to stop our control process, then we can use these instructions for the stop application. Okay, stop application. For the stop application, we will use normally closed instructions. And when we are starting, then we can use our normally open instructions. And after trigger of the input instructions, when we are pressing this, so it will change the state. As you can see, it's here it will not energize, and here it will energize. Okay, when we are pressing, when we are trigger, okay, when our no instruction are triggered, then our software instructions are energized. And when you are trigger our NC instruction, then it will stop the signal for forwarding to others. Okay, it will not energized when we are pressing these instructions. Okay, so have you cleared this application?
Yes.
Okay, so we will move on the next input instruction signal flow. So in our PLC, how to flow our signals? Okay, so yeah, this module is represented to our input terminals of our PLC. Before the slide, we have already discussed about input instructions terminal and output instructions terminal. Okay, when we are looked a Allen Bradley 1400 PLC, then I told our upper side we have input terminals, and in the lower side we have our output terminal. So this section is our input terminal. Okay, and input terminal have our memory address bit. Okay, and memory address bit, it can be 0 and it can be 1. Okay, so it can be say that it is the binary number. Okay, it's work on a binary number. And how it is flow? Yeah, so when we are de-energize, we have de-energize input, so it will not forward, not share the signal to others. Okay, when we are not pressing this symbol, these instructions, so it will not forward the signal to others. And when we are pressing this symbol, so so it will give the give the signal. Okay, so as you can see here, we have wrote a 1-digit number. Okay, 1, and in this section we have 0. Okay, 0. So in the 0 is represented no current flow through this path, and in this number, in the 1, the 1 is represented here we have signal from to others instructions. Okay, if instruction device is on true condition of logic, our logic are true condition when we are pressing our input devices. And when we don't have turn on our input device, then it will show the condition of false. Okay, logic conditions are false when input devices are off. Okay, and our input terminals are connected to our field input devices. Okay, so our field input devices are share the signal to our input memory input module of PLC, and our input module PLC are shared the signal to our logic. It can be 0 and it can be 1. Okay, when share the 1, then our instructions are turned on, and when it will share the 0, then our instructions are not done. Okay,
Okay.
any doubt?
No.
Okay. So in this slide, we have input instructions on and off operation. Examine if closed XIC input instructions. It's have a different name of normally open instruction. This input instructions works as a on and off condition. Okay. Note energize input. When we are putting this symbol in our program, so it will not energize. Okay, it will show not energize. And when energize input, when we are pressing this input instruction in our program, then it will show one number, and number is represented to our true logic. Okay, when memory address bit is 1 memory address bit is 1. Okay, so the logic state will true. The logic state will true. When memory address bit is 0, ये 0 है यहाँ पे 0, the logic state will off. Okay, means false. It will not share the signal to another instruction, and it will forward the signal to connected further instructions. The green highlighted represented the true logic state. Okay. And in the next slide, we have examine if open XIO input instruction. Okay. And before the slide, we have discussed examine if close input instructions. And in this slide, we have XIO input instructions. So it will represent it look like, and it will represent it look like. So note energize input. This input instruction works opposite to the instruction of XIC. Okay. And note energize input. When you are not pressing this symbol, so it will show the turn on condition. It will show the one address bit in the memory. Okay. In a PLC memory, it will show the one number when you are not pressing this instruction. And when energized input, when you are pressing this symbol, then it will show the 0. So 0 means the logic state will false. It's mean it's not forwarding the signal to others instruction. And sometime we can call it as a second name of normally closed instructions. And the green highlighted represented the true logic state. Okay. So here input instruction true false operation. So here it is the final step of input instruction. So basically we have to discuss two types of instructions. One is examine if close, and the second is examine if open. So our examine is close look like, and open look like. So it is the for condition, it is the true condition. Okay, in the true condition, when we are pressing this symbol, then it will forward the signals to others instruction. And when we are pressing the XIO instruction, then it will not forward the signal to others. And these here, these are showing our program. Okay, when we are downloading a program in a PLC, then it will in a run mode, and it is a show the power. Okay, and it will not forward, but these symbol are represented the turn on condition in the initial way without energized. Okay, when we are pressing, When we are pressing, then it will on and it will off. Okay. The input instructions is always placed in the left hand side of the ladder logic diagram. Okay. So always our input ladder logic placed in the left side of our program. Okay. So here we have and our input instructions session. So any doubt from the input instructions related, you can ask me.